Hello again. This is a Math Club reflection coming to you from the College of DuPage, and the title of this video is Guessing in Math, a Most Delicate Relationship. This relationship is at the highest and lower levels. And how does this work in the most serious of math research? And how could it be applied to a multiple choice situation, such as the upcoming Amatic contest? A wonderful book is How to Solve It, A System of Thinking which can help you solve any problem by George Polya. Here is his picture. Perhaps his best point is that learning must be active. As Polya said in a lecture on teaching, mathematics is not a spectator sport. How to Solve It gives many ideas for mathematicians of all levels who find themselves out on such a playing field. Polya suggests an iterative process. Start with a deep understanding of the problem. Make a plan to try to solve the problem and carry out your plan, and then see, have you really solved the problem or not? And you iterate back, deepening your understanding, revising your plan, trying a different plan, and going so on and so on until the problem is solved. Making a plan is about the approach to the problem. And Polya suggests many solution techniques or plans. And solving a simpler problem is a very strong one. We're not really going to address it here, but the one we are going to talk about is called guessing and checking. Now, serious guessing and successful checking can lead to a mathematical conjecture and significant mathematical research, which is a very good thing. An example of a conjecture and checking is the Goldbach conjecture, which is a yet unproven conjecture stating that every even integer greater than 2 is a sum of two prime numbers. The conjecture has been tested up to, this is 400,000 million billion trillion, 400 trillion. Goldbach's conjecture is one of the oldest unsolved problems in number theory and all of mathematics. This is one of many conjectures. The list is very long, very diverse, and still growing. A conjecture creates a summit to be scaled, a potential vista from which mathematicians can see entirely new mathematical worlds. In mathematics, the role of these high peaks is played by graded conjectures, sharply formulated statements that are most likely true but for which no conclusive proof has yet been found. These conjectures have deep roots and wide ramifications. The search for their solutions guides a large part of mathematics. Eternal fame awaits those who conquer them first. And, as you know, conjectures could be proven or perhaps disproven by finding a counterexample. Remarkably, mathematics has elevated the formulation of a conjecture into a high art. The most rigorous science cherishes the softest form. A well-chosen but unproven statement can make its author world famous, sometimes even more so than the person who provides an ultimate proof. Poincaré's conjecture remains Poincaré's conjecture, even after Gregory Perelman proved that it is true. And, analogy with mountain climbing, Sir George Everest, the British surveyor general of India in the early 19th century, never climbed the mountain that today bears his name. Now let's go to perhaps a lower level kind of thing, but a more immediate thing. How does guessing work on the upcoming Amatic exam? Is it a prudent strategy? As you perhaps know, there are 5 possible answers on each of 20 multiple choice questions which must be completed within an hour. 2 points are awarded for each correct answer, and 0.5, 1/2 point, is deducted for each incorrect answer. And you get 0 points for an unanswered question. And the limited time means that the most important checking part of guessing is limited. Let's examine the expected value, and as you know, the expected value of a random variable x is the summation of the values that x can take on times the probability that x happens. And so that's the expected value. It is something that we calculate, but you have to think, what does it really apply to what we're talking about? So let's look at the situation where you do a total guess. A total guess says you get 1 out of 5 possibilities to have the correct answer, earning 2 points, but 4/5 of the time you'll get -1. Well, if you add this together, the expected value is 0. Because you get 2/5 minus 2/5. And you say, well, that's the same as leaving it blank. Well, not really, because 4/5 of the time you will end up with -1/2, even though the average, someone wins occasionally, gets you all the way back to only 0. Now, if you can eliminate one answer, that means that there are 4 possibilities left. And there is a job in eliminating one answer. But that would be, you could earn 2 points, 1 out of 4 times, but 3/4 of the time you would lose a half point. Now that gives you 1/8 as the expected value. But realize you never get 1/8 credit. There is no partial credit. And so really 3/4 of the time you get -1/2, and 1 time out of 4 you would get 2. Suppose you could eliminate 2 answers and guess. So it would be 2 times, there's 1 out of 3, plus, -1/2 times the other 2/3. And if you do this this calculation, you get that this is 1/3. Again, you don't get 1/3 point. There is no partial credit. 2/3 of the time you will lose 1/2 point. Suppose you can eliminate 3 answers and then guess. Well, here you get 1 out of 2 times, you get 2 points, but you also half the time lose a half point. On an expected value, that gives you 3 out of 4. So even the sharpest guessing approach, if you were possibly able to eliminate 3 answers and guess effectively, this underperforms solving the problem by almost 250%. The way I ended up with that is I take 2 points and divide it by 3/4 point, which is the expected value, which is 233 and change percent. So guessing is underperforming really solving the problem. Also note that in spite of this expected value calculation, your guess will far more often result in a net deduction in your score. Eliminate potential answers also is time consuming. So working a few problems as correctly as possible is the best approach. Realize that this is not an easy test and try to have some fun in taking it. It is about enjoying the journey. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself, because self-care is important, and take care of each other because we're all in this together. God bless you all.